Hey everybody, today we're going to be talking about lipids. Lipids are going to be oils and fats and waxes, and contrary to popular belief, lipids are actually really important. We just happen to go nuts about lipids when it comes to diet and physique, and there's been tons of research on lipids over the last 30 years or so, but we're gonna spend a little bit of time talking about dietary fat and where we get all this stuff from. So look at this image here. This is dietary fat right here. It's a cute little pig, if you can tell it is. We get fat from lots of different places, both animal and plant sources. And we get it in the form of something known as a triglyceride. Um, we also have phospholipids and sterols. I think we've heard the phospholipids before. We think of a phospholipid membrane that's located around your cells. We have fat located all over our bodies. So it's not just around your stomach. Every part of your body has fat cells. So let's talk about the triglyceride here. This is a triglyceride molecule, and the reason it's called triglyceride is this green guy over here is a glycerol. It's kind of cut off at the bottom, I apologize. But this is glycerol, and on each one of these and there would be originally an H here. If this wasn't connected, just pretend there's an H right here. In fact, I'm just going to go ahead and write it in just so it feels like an H. Let's put that in here. And pretend these were not connected. Okay, so we have an OH group or a carboxyl group here, and an OH group and a carboxyl group here. Okay, and it's not connected, so this whole thing right here, is one item, a glycerol. These three are fatty acid chains, and they are made up of carbon and hydrogen. Well, if I wanted to combine these on here, you'll notice there's a way to combine these would be the same way we combine carbohydrates, and it's known as that condensation reaction, where we produce water. So we would combine these and we would clear all this out again. And boom, we've got a triglyceride. Looks very different from the structure of glucose, right? The glucose was a ring with C6H12O6 and a 1:2:1 ratio. Here, definitely no ratios. Tons of carbon, tons of hydrogen in three long chains. So triglyceride. Okay. So triglycerides make up about 95% of our dietary fat, and the fatty acids that you see here can be identical or they can be different looking. And we'll talk about the different ones and the structure and what that means for us as human beings. So some of the fatty acids are classified as essential because our body is lacking in the enzymes that are necessary to synthesize them. And so it depends on their supply through food, right? So essential fatty acids are called essential because our bodies cannot synthesize or create them. So we have to get them from the foods that we eat. I hope that makes sense. Let's talk about where we can find some of these things. Essential fatty acids are found in plant oil. So we could talk about sesame seeds. We could talk about corn. We could talk about walnut oil. Those are all plant oils. Palm oil, even. So looking again at this structure, this triglyceride structure, we said here is the glycerol, right? And the glycerol has something known as a methyl group on it. That's CH3. CH3, that's the methyl group. And those methyl groups and carboxyl groups, COOH, if you remember your chemistry, are located on each end. So let's move forward here and talk about the differences when they're not identical. So this looks like your regular old triglyceride, but then here we've got a little kink in it, and it's caused by this double bond right here. Okay. So what I'd like for you to do for a moment here is I want you to go back to your vocabulary that you will have for this nutrition unit. And I want you to spend a minute researching saturated fatty acids, unsaturated fatty acids. Then also look for monounsaturated fatty acids and polyunsaturated fatty acids. There's two more that I'd like for you to look at: omega-3 fatty acids and omega-6 fatty acids. Take a moment to research those. Feel free to use any sources online. Whatever you use, make sure you cite. You can pause the video here for a moment. Okay, so let's talk about a saturated fatty acid. A saturated fatty acid is with the maximum number of hydrogen atoms, which is 4 on each carbon. So, we've got 1, 2, 3, and this is a bond. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. There's 4 bonds. An unsaturated one is where 2 hydrogen atoms are missing. And when you have 2 hydrogen atoms that are missing, we have a stronger bond, or a double bond, that's created between the 2 carbons. And that's what makes it unsaturated. A monounsaturated fatty acid would be just one single double bond. So what you see here, this is a monounsaturated. But if you just imagine for a moment that we added another double bond here and we took away these 2 hydrogens, okay? Now we have 2 double bonds. So that would be considered a polyunsaturated fatty acid. Very good. Okay, so this is where things get complicated. Omega-3 fatty acids are polyunsaturated fatty acids that have the first double bond located between the 3rd and 4th carbon. So it would technically be located right here. That's an omega-3 fatty acid. So what would an omega-6 fatty acid look like? You got it. It'll be a polyunsaturated fatty acid that has their first double bond located between the 6th and 7th. So if we count them, 1, 2, 3, 4, 5, 6, and 7. So this is an omega-6 fatty acid. All right. So there's a lot of research out there that shows that an optimal balance of omega-3s and omega-6 fatty acids is really important in human diet, specifically for inflammation and immunological responses. A really neat part of fat. But fat can also be a problem, so we'll get to that in just a moment. All right, we talked about 100 grams of carbohydrates and how much energy that would produce. Well, let's think about 100 grams of fat. 100 grams of fat would produce 4,000 kilojoules. That's a significant amount. It's actually about 3 times more than carbohydrates. And these triglycerides can be stored in adipose tissue or fat tissue, which builds up an energy store over a long period of time. Hence, people have a gut on their bellies. They have a lot of fat storage, and it's just kind of sitting there like a giant bank of energy. Let's talk about that. Fat also has important value to it. Fat is going to protect your internal organs, which we don't really ever think about, but it's also insulation for us, or what we call thermal insulation, and helps control our body temperature. It also, believe it or not, plays a major role in the synthesis of hormones and vitamin D. Vitamin D is a sterol. Think about steroids, similar to sterols. And dietary fat also